Hi, I'm Dan Taylor, a program manager on the Visual Studio Diagnostics team. In this video, I'm going to show you how we have made it easy for you to measure the performance of your code without leaving your favorite tool, the debugger. First, I'm going to show how PerfTips allows you to measure how long code takes to run just by setting breakpoints and stepping. Then I'm going to show you how you can use the Diagnostic Tools window to view the CPU and memory usage of your app, and then how you can view a detailed breakdown of memory usage by taking snapshots. Everything I will be showing today is available in the free community edition of Visual Studio 2015. Here I am in my application photo filter. When I press F5 to start debugging, you'll notice that it takes a long time for the application to start up and for the pictures to be displayed. This application downloads some pictures from the cloud and also loads pictures from my local photo library. I believe that loading images has something to do with this performance issue, so to test that hypothesis, I'm going to set a breakpoint in the load images method and start my application again. Once I hit the breakpoint, I can then start stepping through code, and I will see a PerfTip displayed that tells me the previous line of code took up to 6 milliseconds to run. The less than or equal to sign indicates that there is some debug overhead included in this number because we are running a debug build with the debugger attached to the application. I can continue stepping through my code one line at a time, and I see when I step over the getImagesFromCloud method, the application is running for a while, and then when this step completes, I will see that it took about 6 seconds to get the images from the cloud. I can also time sections of my code by using breakpoints. So if I want to see how long it takes to run the remainder of the method, I can put a breakpoint at the end and then press F5 to run to the breakpoint. Here the PerfTip tells me that the remainder of the code in this function took only about 1.7 seconds to run. I can click on the PerfTip to see more performance information about my application in the all-new Diagnostic Tools window. If I reset and zoom out a little bit, I will see all of the CPU memory and debugger events that have occurred so far in my application. By hovering over the break events track, I can see the history of the PerfTip values by hovering over each event and looking at the duration value shown in the tooltip. This information is also available in the duration column in the events table below. Focusing in on the getImagesFromCloud method, I can see that this is where that step occurred, and I can look at the CPU and memory characteristics of getting images from the cloud by hovering over the graphs. I noticed that at the start of the getImagesFromCloud call, there was a period of high CPU usage, and by hovering I can see that about 22% of all of my processors were used, and because this is a 4-core machine, this indicates I was almost fully utilizing a single CPU. Then I can see that the CPU usage was relatively flat for the remainder of the time, indicating that there is some network I/O occurring here. I'd like to drill further into the getImagesFromCloud method, so I'm going to stop debugging and set a breakpoint in the getImagesFromCloud method and run my application again. I can see that this method does two primary things. The first is getting a list of images from this cloud, and the second is downloading the images one at a time. I could time each section of code by using breakpoints, but this time I'm going to use a neat feature of the debugger called Run to Cursor. I can right-click on a line of code and say Run to Cursor, or press Ctrl F10, and that will run the debugger to this point in code, and then PerfTips will tell me that it took about 900 milliseconds to get the list of pictures from the server. I can then run to cursor again on the last line of code to time how long it takes to download the pictures one at a time. I can see that this took the majority of the time at about 4.6 seconds. To make this run faster, I believe that I might be able to parallelize the download of the thumbnails so that it will complete in less time. I'm going to change my code to do just that, and then I can time this again. I'm going to go back and set a breakpoint on the Get Images from Cloud method so that I can see how much of an improvement we've made. This time, when I step over the Get Images from Cloud method, we'll see that it runs in less than 3 seconds now, when it was almost 6 seconds before. That's quite the improvement. Now, when I was running my application previously, I noticed that there was a sharp run-up in memory usage after the Get Images from Cloud method. So to dig into this, I'm going to go to the Memory Usage tab, where I can then take snapshots. By clicking Take Snapshot, this will establish a memory baseline that I can use to compare against future snapshots. I will step over the Load Image from Disk method, and here we can see that the memory is continuing to increase during this step. I can see before the step started, memory was about 24.7 megabytes, and then at the end, memory was about 44 megabytes. To understand what's going on, I can take another snapshot, which I can then compare against the first snapshot. By looking in the table, I can see that there was about 690 objects added on the managed heap between the two snapshots. I can click on this to see a list of all the objects that were added. The one that stands out is the bitmap image item, as this is the in-memory representation of the list of the thumbnails that are shown in the list on the left-hand side. There's only about 10 thumbnails displayed on the screen. However, there's 135 of these objects that are being added in memory. I believe that I might be able to reduce the memory usage during this Load Image from Disk method by changing the bitmap images to load on demand as they are displayed rather than all up front at once. Down below in the table, I can see which types are referencing these bitmap images. When I click on the photofilter.image item, I can see that this one is the one that's referencing almost all of the bitmap images at 133 references. I can right-click on this type and say Go to Definition. And here I can see that the bitmap image is used for the mPhoto variable. By scrolling down through the code in this class, I can see that the mPhoto variable is referenced in 2 places. The first is the photo accessor, which already does the on-demand loading of the bitmap image. And the second is the Load Image from Disk method, which is the one that is loading the bitmap image on application startup. I'm going to go ahead and comment out the second implementation because I believe this will fix the memory problem. I'm going to run my application again, and this time I'm going to see if I've improved the memory usage after the Load Image from Disk call. Now when I step over this line of code, we'll see that the memory usage stayed below 30 megabytes at about 28.1, where it was about 44 before. That was a quick tour of the debugger integrated performance tools and how they make it super easy for you to solve performance issues in your apps. If you'd like to know more, check out our blog post on the Diagnostic Tools window at aka.ms/diagtools window and our blog post on PerfTips at aka.ms/PerfTips. Thank you for watching.